So this is the another problem for finding the reaction at support A and support at B. So in this, typically it is a simply supported beam section. In this, the beam AB is a beam. Here the whatever the forces which is acting is a triangular force. In the triangular force, the concentration force will be acting at one third from this end and 2/3 from this end. So as I shown here, this is the triangular shape, triangular force. The concentration, so all this force, complete triangular force, will be converted into a concentrated force. This is acting as I shown here. So this is the concentrated load. So concentrated load, it is acting. So consider this is the total length. So 2/3 from this end and 1/3 from this end. So the load will be acting. The concentrated load will be acting at this length. Okay. So I will further the same whatever it has been done, whatever teach it. So same thing it will be used here. So the whatever the triangular force will be there, the concentration force will be acting at here. So 2/3 from this space and 1/3 from this space. So how to convert after placing the concentrated load, what is the magnitude of that force? How to find out that I will tell you later, but try to know this is a triangular force and 40 kilonewton is a concentrated force, another 60 kilonewton it is an inclined force at an angle of 60 degree. So what you have to do is you have to resolve the forces. This is a hinge and this is a roller. You will get a one single reaction like this. One single reaction will be there, and for an hinge here, you will get two forces here. One horizontal force and another is a vertical force. Two forces will be acting. So AX and AY. So two forces AX and AY. So you have to find out these two reactions, and another reaction is RB. So these three reactions you need to be found out. So first in order to find this, so what you do is, see here, only AX one horizontal force is there. So there is no vertical forces, there is no another horizontal forces there, but there is an inclined force is there. If you resolve this, so if you resolve this, the forces will be two forces will be there. One, it is the vertical force 60, this will be theta, will be here, 60 will be here. So this is 60 cos 60 degree, this is sine 60 degree. So this will be if you resolve the forces, this one, so you will get the resolving force like this. One is horizontal, another is a vertical inclined for the inclined force. This is the 60 sine 60, this is 60 cos 60. So you have to resolve this. So whatever the forces, so first I will find out this AX. So you take, there is a three equilibrium equation, sigma fx, sigma fy and sigma fx. Sorry, sigma fx is equal to 0, sigma fy is equal to 0, sigma m is equal to 0. First I will use the sigma fx. So sigma fx I will use it. So when I'm using sigma fx, so one whatever the sigma I am using, right side movement of the right side is positive I am using. Okay, so here you can see this. So it is moving right hand side, so I have used AX as positive. But when you resolve this inclined force, this force will be acting moving towards the right hand side. So moving towards the right hand side, so that's why, so I will use the negative sign convention, 60 cos 60. So force is 60 cos 60, so I'm using force as 60 cos 60, but it is moving in opposite direction, so it is negative. So finally you move this forward to this side, so finally you will get the 30 what you resolve this, you will get the 30 kilonewton. So finally I found out the AX. Okay, next what you do is, so in order to make it easy, you, because here two forces is there, you nullify to nullify this, and to find out the RB, what you do is, better you take down the moment at A. So finding the moment at A, later what you do is, after finding the moment at A, you will get RB. So after finding RB, if you take the vertical forces, sum of vertical forces is equal to 0 means everything is a known, only unknown will be RB. So AY. So if you know AY, so rest of all whatever the determination unknown reaction should be found out, it will be cleared. So what you do is better you take a moment at A. Moment at A is equal to 0. You take anti-clockwise direction as positive. It's your wish, you can take clockwise or anti-clockwise direction, your wish. So now I'm taking anti-clockwise direction as positive, so it is moving in a clockwise direction, so it is negative. So 45 into 2, so it is 45 into 2 is negative. Next one is you can see here 40 into 4, so it is moving in a clockwise direction, so it is negative. 40 into 4, so because I have taken in the class other classes I have taken clockwise as positive. For this particular problem, to make it easy to my convenient, I have taken anti-clockwise direction as negative. So you can see here 40 into 4, so it is moving in a clockwise direction, so it is negative. 40 into 4 as negative. Next is here, so if you come to the incline, so there is a two forces. One force you can see here, it is a one vertical force, 60 sine 60, it is 60 sine 60, so that is it will acting at it is acting exactly here, it is acting here. So 1 2 3 plus 5, so 60 sine 60 into 5, so that's what here, 60 sine 60, distance 5 meter, but it is acting in a clockwise direction, so it is negative. Okay. So I have taken anti-clockwise as positive, that's why. Okay, so you can see here RB, so RB into this distance, totally 2 3 4 5 6, RB into 6, so it is moving in anti-clockwise direction, so it is plus RB into 6. If you resolve this, finally you will get the RB is equal to 84.97 kilonewton, so it is upward. So you got the positive answer, so it is upward in direction, the reaction is in upward direction. So after finding the, you have already determined the AX, you have determined AY, you have been RB you have been determined, only unknown thing is AY. So here rest of all the forces are been known, only unknown force is AY. So AY is the vertical force, so you take it vertical force Fy is equal to summation of Fy is equal to 0. So AY is AY it is so here you take upward as positive. So AY and RB are in upward direction, so I am using AY and RB both are in upward direction, rest are all in downward direction, 45 and 40. So 45 and 40 it is in downwards. Next another one force is there here. What is this downward force? Another force is 60 sine 60, it is in downward. Whatever the inclined force is there, I have written here. Okay, 60 sine 60 is a downward direction, so I am using 60 sine 60 as in downward direction. So U is equal to 0. So whatever, finally if you resolve this, finally you will get the 51.9 kilonewton. So whatever the reaction they asked, they you have been determined, but here only in hinge portion you be very careful. In AX and AY the resultant force will be there for the only these two forces. What you do is take a resultant force RA, this is RA, you make it because you are finding at the point A. RA is equal to square root of AX square plus AY square, AX square here, AY square here. So AX, AY both you have been determined, just you insert the value of AX and AY value and find out the resultant force RA, so that is 60.02. but at what angle it is acting, you have to be checked. Okay, so you know AY is a vertical force, AX is a horizontal force. Tan theta is nothing but opposite by adjacent. Opposite always it will be in a vertical force, adjacent will always remain a AX is the adjacent. Okay, so what you do is AY divided by AX you take it. So theta at what angle it has been acting is equal to theta A is equal to tan inverse of modulus whatever the answer, if you get negative also you have to take it positive only. That's why the modulus of ay divided by ax. Insert the, you already determined the ax value and ay value. Ax is 30 and ay value is how much? Ay value is 51.99. so just insert the values and find out the theta value. So this completes this problem. So this problem number is 7.51. so I will send the snap. You can note down in the your notes.